Welcome back to True North Mechatronics. In our last episode, we designed the side rails of our battery box and integrated rectangular sockets to retain the battery tray and the top for this box. The top of our battery box utilizes the triangular truss structure to help reduce plastic usage and print time, and it also functions to add compressive rigidity. When you physically press the side panels onto the tabs of this top plate, the truss prevents the 3mm profile from buckling under the assembly force. Design, engineer, deploy. Let's get into the CAD. Let's begin by creating a new body and a new sketch on the XY plane. And we're going to design this in two parts using the polyline tool here. Our tray, or our top, is going to have 3 tabs. So let's create 3 tabs. And we'll come back in and we'll straighten out the horizontal and vertical constraints here in a minute. Right, so now that we've got that, let's find everything that isn't horizontally or vertically constrained. We're going to click on those. And we're going to constrain them. So there we go, that straightens up the profile. We're going to make this central tab so that it's symmetric around the y-axis. Now we're going to set the bottom of our profile to 94mm. Let's set the tabs so that they're all the same width. We're going to set them to 10mm in length. Now we're going to set the tabs so that they are also all the same height. So let's grab the edges of the tabs here. And we'll set them equal to each other, and we're going to set the length of these tabs to 3mm. We're going to set the central spacing between our tab sets so that they're equal, and also so that they are 22mm. And now finally, we're going to tell FreeCAD to simply balance these remaining edges so that they're the same length. All right, so now that we've done that, we can set the length of this left-hand side here, and we'll set that to 29mm. Our shape is now fully constrained, so we can close out of the Sketcher workbench. And we're going to pad this shape out to 3mm. Next, we're going to mirror this shape across the x-axis. So let's grab the mirror tool. We're going to go in here and we're going to say that we want to select the reference. The reference for our mirroring operation is that edge there. So we can accept this and close out. And now we have the basic shape of our top panel here. We're going to add that triangular truss pattern now. So we're going to use the polyline tool for that. And we're going to create some symmetrical triangular shapes. We'll constrain them horizontally and vertically in a minute. Let's get the basic shapes roughed out first. Okay, there we are. So we're going to grab every vertical or horizontal edge that wasn't properly constrained, and we'll constrain it. And we're going to set the bases of all these triangles so that they are equal. We're going to set the lengths of all of these triangles so that they're equal. There, we never constrained that one vertically, so let's grab that one. Now, next, we need to constrain them with respect to each other. Let's set the inside of these two triangles so they're symmetric around the y-axis. Let's set the edge of this triangle so it's symmetric around the x-axis. And let's toggle on the construction geometry and let's create construction lines between the gaps in our triangles here. And let's make sure that those are all constrained so that they are horizontal or vertical. And we're going to make sure that these construction lines are the same length. So if you're having trouble clicking on it, just zoom in. There we go. So we're going to set them so that they're equal. And now let's set the length of our construction geometry to 5mm. Now when we move these triangles, they move in a symmetrical manner. So now we just need to lock them into place. We're going to reference the left-hand edge here. We're going to create a 10mm inset from the edge. And let's give the length of our triangular section here 44mm. All right, so we have fully constrained our triangular pattern, so we can close out of this and pocket. We'll accept the default. Now we need to create the mounting bosses on the top of this. This will attach to the screw holes that we put in the top left corner and right corner of our side panels. So let's zoom in. To do this, we're just going to reference the left and right edges of our shape. And with the rectangular tool, we're just going to draw some rectangles. All these rectangles are going to be coincident with the outer corners there. And now we're going to use the symmetry tool to make it so that we can constrain these all relatively simply. So we're going to constrain them across the axis like this. And now that we've done that, we can set the sizes. So let's set that to 8 millimeters. And let's set the vertical length to 5 millimeters. And just like that, all of our mounting bosses are fully constrained. So we can close out of this and we can pad that out to 5 millimeters. Now we need to add holes where the holes in the side panels are also located. So let's create a sketch here. And we're going to create 2 circles. Now, because we don't have any features between the mounting bosses, we're going to take advantage of that, and we are going to pocket these right through the entire width of our battery box here. So let's take the diameters and make sure they're equal. We're going to set the diameter to 2.8 millimeters. And we're going to set the distance with relation to the top edge of our mounting boss here. So let's reference that. And let's bring it down 3 millimeters. So a 3 millimeter offset from the top. And let's center it, so that's going to be 4 millimeters. And just like that, we have fully constrained those holes, so we can close out of the Sketcher workbench. And because we've got a width of 58 millimeters that we're working with here and nothing in between, we're going to pocket this shape right through. Let's try that again. 58. There we are. Let's have a look. So 58 millimeters. Okay, the holes go all the way through from one edge to the other. And now we're going to add some chamfers to the inside edges here. This is purely decorative. There's no structural reason to do this, but it looks kind of neat. So we're going to grab those 2 edges there. I'm just holding down Control. And let's grab these inside edges here. So now we've got 8 edges that we've selected. And let's give them a 2 millimeter fillet. And we're going to grab these edges here. Oh, not quite that one. If you're having trouble, just zoom in. So there we are, we got these guys here. I'm going to begin there again. 1, 2, 3. Oh, that one's done. Let's grab these ones. 1, 2, 3. And do the same with these ones. And just take your time. That way you don't accidentally click on something else. So there we are. So we've got all of those segments selected, and we're going to give them a fillet now of 2 millimeters as well. And there we get that neat looking rounded effect on our mounting bosses. And with that, we have completed the main features of our battery box top. We have a highly rigid truss supported cap featuring our precise 10 millimeter tabs that will fit in with our rectangular sockets that we created in the side panels. In the next video, we're moving on to the floor of our battery box, and this is the battery tray. It's designed to accept the 18650 battery pack that we designed for the TitanBot. We're going to design into this tray a retention ledge on one side so the battery box can't slide, or the battery can't slide all the way through the box. And on the opposite side, we're going to create a compliant mechanism so that the battery clips into the battery box. And this is going to give us compatibility between the Sparkbot and the TitanBot, so that we can just manage one set of batteries. All right, chart your course, build your world. I'll see you in the next one.